Okay, before we start with the calculator stuff, one of the things, now we did some complicated trigonometry, and typically on the exam, you're not going to get the hardest questions, but there might be one or two that are a little bit trickier for sure. So when you're working with a triangle for trigonometry, SOHCAHTOA, it always has to do with the angle that you're talking about. Okay, so it gives us this angle A, and it says label the sides. So first of all, if I go across from the right angle, what's that one? Hypotenuse. And I'm not going to write it all out. We usually shorten it to HYP. And then across from A, across from the angle that you mark is opposite. And that's really important. And the last one is adjacent. And then SOHCAHTOA goes like this. And if I switched it to B, let me do this in blue. These two would switch. Hypotenuse doesn't change, but the other two would switch, right? So it's the angle that you're talking about. And some people in a question, maybe we'll see an example of that in a little bit, and I'll try to point it out, get themselves confused and label the triangle wrong, when really that should be the easy part. Most people are good at that, and then somehow confuse themselves about it later. So define the following ratios. So cosine, if I use SOHCAHTOA, what is cosine? What's the formula? What's the ratio? Huh? Good. What's tangent? Josh, do you know? Good. And then sine? Adam? Very good. So that's a big first step. All the steps with trig, they're all little steps, and they're all pretty straightforward and easy. We put them all together, and you got to get them exactly right. Use your calculator to determine the following to 4 decimal places. Okay, so here's where we're going to have to make sure our calculator's in the right mode and everything. So here's my calculator, and there's a little letter right here, and mine is actually in the wrong mode. It's in R because in grade 12 we use a different mode. So last time I was using this calculator, I guess, was in grade 12, my grade 12 class. And if I put in cosine of 60, what I get is not what I'm supposed to get. This is my test, and I'll put this up on the board, or if somebody asks, I'll tell you. The cosine of 60 is supposed to be 0.5. So that means my calculator's in the wrong mode. This is a surefire test of whether or not I'm in the right mode. So I'm going to put it into the correct mode, set up, and you see DEG there for degrees. And now if I do cosine of 60, I get 0.5 or 1/2. That means I'm in the right mode. Notice on a 2-line calculator, I write it the way you write it on page. That's why these calculators are so great. If you have a job over the summer, take $10 that you earn. If you're taking grade 11 college, buy yourself a $10 calculator that's 2-line that types it out like this. Trust me, you'll be so happy that you did. Bring your own calculator every day. Use the same calculator. You do trig again in grade 11, and you do more. That's a little bit harder. And it's really useful to have a good calculator that types things out the right way. If you don't have a good calculator, you can't really see this one. Ignore the 0.00. This is a terrible calculator. It's business, so it always rounds to do 2 decimal places. But I'm going to do 60, and then I have to hit second function and find cosine. Where's cosine? Here it is. Hit cos, and it still gives me 0.5, but I put the angle in first, and then hit cos with a 1/9 calculator. And if that's the kind of calculator you have, you need to know that. These big ones that you ladies have at the front are like the first kind. You put cos in first, then you put 60. Okay, so sine of 32, try this one. And you should get 0.52. It says 4 decimal places, 99. Did you get that? Anybody not getting that? Sine of 8, 0.1392. Rounded to 4 decimal places. 1391, but the 7 rounds it up, right? Cosine of 27, 0.8910. and tan of 81. You notice that whether it's sine, cosine, or tan really doesn't make the question different. You just hit a different button, right? But it's all the same stuff. And tan is 6.3138. Everybody good? How do you do it? A question like this, where it gives you the answer and you're trying to find the angle. Capital A is an angle. We're trying to find an angle. What's the trick to finding an angle? 1327. I just want to try to memorize that. Brianna? Right. So shift tan 1 point, I forgot already. 327. 1.327. That's how I would do it on this calculator. So 52.999, so 53 degrees. And what about on this other calculator? This one's really messed up for these guys because, oops. 1.327. Oh, 1.327. I have to find the arctan. Where is it? It's on here somewhere, I think. Oh, inverse. Inverse tan. 53.0. So it rounds it for me, right? So you put the number in first, then shift tan on a one-line calculator. Okay, and for this one that has a fraction, again on a two-line, it's really easy. Shift tan, and I just punch it in. So 1235 divided by 1,000 is how that would look. 51 degrees. And on the other one, I would have to do 1235 divided by 1,000 equals, and then shift tan. Same answer. Make sure you can get those. Everybody try those. Everybody get those answers. Okay, let's try a couple of questions here. Oh, I don't have a lot of space. Okay, so I'm going to label the triangle, hypotenuse. And this is the angle I'm going to put into the formula. It's the angle that it gives me. So that's the one I'm going to label the triangle from. So that's opposite. And this is adjacent. And so I know that one, and I'm looking for that one. Opposite and adjacent is tangent. So I write the formula. Tan theta. If you forget one formula or two formulas on the exam, you'll probably be okay. If you forget it every time, you're going to lose marks. That's what I mean by write the formula. A lot of people got that feedback on tests throughout the course. Formula, 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 question mark. That's what it means. Okay, that's the way we do it in math. It's like your introductory paragraph. Tan, put the angle in, 49. Opposite is my x. Adjacent is 35. This is the kind with x on top. Multiply both sides by 35. Right? Those are gone. And I get 35 tan 49. 40.3. Does that make sense? This side looks in my diagram shorter, but the diagrams are not drawn to scale. And it's in the ballpark of 35, so I think it's fine. Okay, next one. Hypotenuse. Here's my angle, so opposite. And the last one's adjacent. I don't have to worry about that one. Which ratio am I going to use this time? Noah, what do you think? The second one. Which ratio are we going to use? Sine. I have opposite, and I'm looking for hypotenuse. Good. Sine theta is opposite over hypotenuse. Sine of the angle that I'm given, 21, is opposite, which is 15, over hypotenuse, which is x. I remember on the last test that we did this trigonometry stuff. Some people just always put x on top because that's how they knew how to solve it. Or they would start with x on bottom and they would just do this. So sine 21, I'll just flip it because Mr. Belair said you just flip it. No, not in trigonometry. That's not what I said. When you have a proportion, when you have fractions, you can flip. But in a case like this, you absolutely cannot. It's not how you solve these. How do you solve these? X and sine 21 trade places. There's a reason why. It's not magic, but I'm not going to go over it right now. 15 divided by sine 21. So this kind, you end up dividing 41.9. And that's quite a bit bigger than 15, but it's not crazy. 21's a small angle, so it makes sense that one of the lengths is longer than the other. Okay. Last one, looking for an angle. So notice the difference between x on top and x on bottom. One you multiply, one you divide. That's a big deal. If you're working on this today, really work on that. No, those steps right there, that's perfect solution. Okay, the last one. Let's get through this. Hypotenuse and adjacent to the angle. So this one is cosine. And this is what some people do. For whatever reason, when they're looking for an angle, they then switch it to the other one somehow. That seems to be when people do that, I find. So make sure that you put things in the right spot. Cosine theta is adjacent, which is 9, over hypotenuse, which is 14. And then this is a kind, we just did it, shift cos 9 divided by 14, and I get theta is approximately 50 degrees. Any questions about that? You sure? Okay, I'm just gonna draw the diagram for this really quick because I want to give you some time to practice. From the top of a fire tower. So that's like in a national park or something, they have fire towers to watch for fires. The angle of depression to a log cabin is 26 degrees. So here's a log cabin. So there's my triangle, and this is what people do. If you remember, they go like this, 26. Well, why is that wrong? Because an angle of depression is always from a horizontal, and that's how we would measure it. So it's here, 26, which puts it here, 26. Okay, so really, really watch for that. But I'm sure that sounds familiar because that's something we've talked a lot about. Determine the distance to the cabin from the base of the tower if the tower is 75 meters high. So 75 meters, and the triangle ends up looking like this. Whoops. 26, 75, and x. And then I would just set it up like the last ones and solve it. Any questions?